Different type of joke today. It's on the board. Right then, second, if not the first video actually, now I say that, on coastal landscapes. We're going to look at just the wave types and their characteristics in today's video. Should be quite a short one. So our starting point here is, why do waves happen, or why do they occur? No actual slide here on what a wave is, because actually the explanation of how they occur will actually dictate what they are as well. A wave is caused by a wind travelling over an open surface or body of water. That action creates frictional drag on the surface of the water, leading to wind waves. But at GCSE level, you get away with just simply calling those waves. The sentence I've put up on the board there is related to Cornwall and Devon, where generally speaking our wind waves or waves come from a prevailing wind from the southwest, which causes frictional drag on the Atlantic Ocean surface. If you want to see an example of frictional drag in action, if you take a loose piece of A4 paper on a table and brush your hand over the top of it without actually touching it, you'll actually see that it will have the ability to almost move that piece of A4 paper, and that's the concept of frictional drag, because the air above the paper is causing drag on the actual paper itself. Now, waves are not to get confused here with tides. Tides are not actually covered by the GCSE spec, but that's the gravitational attraction of the moon and sun causing the ocean water to either move towards or move away from that. Now that causes two high tides in the UK every year, every day I should say, where water is pulled towards the moon as the Earth rotates towards it, and also it pulls away from that as well as we're facing away from the moon as well. So it's the concept that tides would naturally bring the sea's water towards the land at 2 times a day in the UK. However, waves are the concept that the wind blowing over the surface creates friction, which means that the waves start in deep water with quite a circular motion. However, as they would naturally approach the beach, the bottom of that wave, the bottom of that circular motion, will begin contacting with the seabed, and it acts as a source of friction, which therefore means the base of the wave is slowed down, and that eventually will cause the top of the wave that hasn't been slowed down by friction to break over the top of the bottom of the wave, and that's when you see them crash onto a beach. We've also got 2 extra words there, swash and backwash, I'll come to in a second. Thing for you to remember regarding waves, though, is that they're formed by a wind on a surface of water through frictional drag. Alright, some key terms for waves here. I'm going to start with fetch in red. You'll see a map there to the right hand side. Fetch of a wave is quite simply how far the wave has travelled. With this lovely map of the UK up on the board here, hopefully you can see that towards Land's End, or coming from South America, those waves travel 8,000 kilometres in distance. What that means is there's an awful lot of time for the wind to impart energy onto the sea through that process of frictional drag, and as a result it makes it the largest waves are generally found here in the southwest, and also in western Scotland as well. You've got a very large fetch on that side as well. So the concept there being that because the wave is approaching for a very long time, the wind can impart that energy into the surface of the sea far more, and as a result you'd expect larger waves there in the southwest and also northwest. When we can take the North Sea waves, those are rather small 650 km and 300 km waves, they're much smaller because the winds don't have as much time to impart energy through frictional drag. This, however, does not mean that most erosion occurs on the west. As a matter of fact, it's the other way round. Most erosion occurs on the east of the United Kingdom. And the reason for that is it's not just the wave type that leads to erosion. It's also the geology is a big example. If you take northeast England, Flamborough Head as an example, has the fastest eroding coastline in Europe because the geology is boulder clay, which erodes at about 1 to 10 metres every year. Take Land's End, where you've got granite and slate geologies there. The reality is they erode like 0.01 millimetres per year, despite these very large waves from South America. So our first keyword there is fetch. That's how far a wave has travelled. When we move on, we get the additional wave terminology, which I'm hoping some of you recognise from physics as well. In terms of wave length, the distance between two crests. Wave height should be relatively straightforward. It's the difference between the trough and the crest of a wave. Wave frequency, the number of waves that pass a certain point. Often that is done in minutes, or the amount of times that a wave breaks onto a beach within a minute. We've also got swash and backwash, which is covered in a separate video. Swash is material moving up the beach, whereas backwash is material being removed down the beach. We'll apply these terms in a moment when we relate them to the different types of waves. So our two different types of waves here, we get constructive waves and destructive waves. This is at a very, very, very straightforward, simple level, but we take constructive waves first. Constructive waves you associate with summer conditions or anticyclone conditions or high pressure conditions where winds are weaker. If you have weaker winds, that means there's less frictional drag on the surface of the water itself. So as a result, you have lower height waves. That therefore means less erosion. In addition, you have longer waves for essentially the same reason, that the frictional drag is lower. And as a result, these longer waves will break onto the beach in like a rolling fashion. And as a result of them rolling onto the beach, they have a very strong swash as they simply roll onto the beach as opposed to crash onto the beach, but actually quite a weak backwash because they simply don't have enough forward energy to create a backwards energy to actually drag stuff off the beach. So what this therefore means is you get deposition occurring on a constructive waves and beaches will form. In terms of constructive waves, they're far less common than destructive waves. You'll have around about 6 to 9 waves a minute when we consider constructive waves. That's the opposite to destructive waves. They're more common in winter, but don't get me wrong, you can get them all throughout the year. Associate them with low pressure weather conditions. You'll have a stronger wind, which therefore equals stronger frictional drag. It means that the waves are a higher height, and that means more erosion because they crash from a higher altitude, if you like, a higher height, and they will crash onto the beach as opposed to roll onto the beach. Now this is really important because you can see in there in the diagram on the bottom right, look how much higher those waves are. They crash with that force of gravity as well. It leads to more weight being impacted onto the beach, and that therefore means these waves have the ability to scour material off the beach. That leads to sediment being removed during destructive waves. They have a stronger backwash than swash itself. Now, because it's stronger winds as well, you also get more waves per minute. You get around about 12 waves a minute, which you say is more than or equal to double the number that you get in constructive waves, which was 6 previously. Stronger winds make them shorter in length. Now, I've gone through that quite quickly, so hopefully the final slide will make this a little bit easier. This is your key summary points on these types of waves. If you don't have this down in your notes in your book, I really would suggest making a quick note of these, and it would be a really, really good idea to also make sure that this is put somewhere nice and prominent at home so you kind of constantly see it, because it's quite likely a question on this is going to come up in relation to your exam. Hopefully that was all useful, all fine. Any questions about it, please come and see us down in HA. I'll happily go through it with you.